Previously, we talked about some of the different properties of matter, whether they're physical or chemical properties. Now we're going to talk about whether we have a physical change or a chemical change and how you can identify which you have, physical or chemical changes in properties. We'll start with the definitions. What are the changes in matter? So first we have physical change. A change in the physical form or state of a substance without changing its chemical identity is considered a physical change. When a physical change occurs, no new substance is formed. So as long as we're not making something new, then it is considered a physical change. On the other hand, a chemical change is usually due to a chemical reaction. And this is a change that results in the formation of one or more new substances. The new substances have different chemical and physical properties than the original substance. So let's focus on the physical changes first. So the three major physical changes that we see are the change in physical state. That's when we change from a solid to a liquid or a gas, that type of thing. We'll go into more detail on that in a moment. Changes in shape or size. So if I take a piece of paper and I wad it into a ball, it's still a piece of paper. It just looks a little different. If I tear it in half, it's still a piece of paper. It just looks different. Those are considered physical changes. I'm not making something new. It's still paper. So if I crush something, if I make it larger by balling it up, if I hammer it down and make it flatter, those are all physical changes. Number three is if I mix one chemical with another without a chemical reaction occurring. I believe this one is the hardest one to figure out because it's hard to tell did a chemical reaction occur or not. But I want you to think about some of the things that you do. So let's take sugar and water. You know that water looks a certain way. It's clear, it's colorless, it's a liquid. And sugar is a white crystalline solid, and we can define them a little bit by how they taste. Water really doesn't taste like anything. Sugar does. It has that sweet flavor of sugar. We mix them together, and when you're done, you now have a clear, colorless liquid, but now it tastes sweet. So it's taken on the properties of the sugar. What we see is that the two properties have mixed. We haven't changed it completely. We didn't go from sweet to bitter or sour or something like that. We didn't go from clear and colorless mixing with white and turning pink or green or orange. So we didn't see a major change there. So this is telling us that we have a physical change. If I take red food coloring, add it to water, and the water turns red, that's not a chemical change. Nothing has happened to the water to make it do anything different. It's just taking on the properties of that red food coloring and becoming red. If it had changed color to green, that would be something different. If I put chocolate chips in my cookie dough, well, it makes it chocolate chip cookie dough instead of regular cookie dough, but it is not making something new. It's not a new chemical that's being formed, just a mixture of cookie dough plus chocolate chips. So those, as I said, mixing is probably the hardest one to figure out, but when we mix things, if it just takes on the properties of the other one, then we probably haven't had a chemical reaction. We'll begin talking about what chemical changes are in a moment, but let me finish with the physical states. I want to talk more about that first. As we discussed physical states, we only discussed three physical states, the solid, the liquid, and the gas. We ignored all the others. And so these are the changes from one state to another. Some of these you already know, some of them you may not have heard of. So you will need to know these physical state changes and what their names are and what they mean. So first we have melting, and melting of course means going from the physical state of a solid to a liquid. And its opposite is freezing when we go from a liquid to a solid. Notice that we don't change the chemical that's present. So if I looked at water and I wanted to say it was in the solid state, I'd write H2O with an S, and then we'll put a little arrow and say it turns into a liquid. It's still going to be the same formula, H2O, but now it'll have an L instead of an S. So we haven't changed the formula. The chemical's still the same. That's how we know that this is a change in the physical state. And when we freeze, of course, it goes the opposite direction. It goes from H2O liquid to H2O solid. So I expect most of you already know melting and freezing. You probably also know the word boiling. So boiling is when you have a liquid that turns into a gas. And for that, we would write an equation, if you wanted to write it as an equation, as H2O, L for liquid, turns into, arrow, H2O gas with a little g. And we could do the same thing for condensation, which is the opposite of boiling. This is where we're turning something from a gas into a liquid. And you'll see that on a regular basis. You probably see it in the morning when you go out to your car. We call that the dew point, but we see that there's a liquid on the window that came from the gaseous water in the air. So in that case, we turned H2O gas into H2O liquid. And our last two you may not have heard of, so we'll talk about those a little bit more. First, we have sublimation. Sublimation is when we turn any substance from its physical state of a solid directly into a gas. Most of you have probably seen this if you've seen dry ice. So dry ice is a solid, it turns into a gas, and it's called dry ice because it doesn't turn into a liquid. It skips the liquid stage and passes directly from a solid to a gas. Sublimation also occurs around you when you see things like mothballs. So those are solid little balls that you can smell later. That's because they're turning into a gas, and that's true of certain solid air fresheners where they turn from a solid and then that seems to disappear. When it's disappearing, it's actually subliming, it's turning into a gas, and usually you can smell that as it diffuses around the room. Another one that you might not expect is your ice cubes. So if you go into your freezer and you leave some ice cubes in there for a month or so, you'll notice that they've kind of shrunk. They aren't touching the sides of the ice cube tray anymore. What that shrinkage is that those ice cubes are subliming so that the water that's there is turning from the solid into a gas. And what's interesting about it is that it's depositing those gas crystals on the walls of your freezer. So you'll see that there's sometimes frost on the sides of the freezer, unless of course you have a frost-free freezer, which we'll talk about in a little bit. And that leads us to our last physical change of state, and that is deposition. Most people have not heard of this. So deposition is when we turn something directly from a gas into a solid. And that's what you see in your freezer when you see those crystals on the walls of the freezer. Those water crystals are coming from gaseous water, which we call humidity, that is in the air, and they are depositing onto the surface of the freezer, onto that solid surface that's cold. When you have a frost-free freezer, what happens is that the walls of the freezer are heated momentarily, and what that does is it melts the frozen solid that you see on there that's been deposited on the walls of the freezer, and it starts to melt. It turns it back into a liquid. It runs down and collects underneath your freezer. So that's how those frost-free freezers work. You may have seen other types of deposition and sublimation. So for instance, if you've ever left ice cream in your freezer for a month or so, you'll notice that the ice cream has become kind of sticky and gooey, and that there's crystals forming on the lid or the packaging of the ice cream. The ice cream becomes gooey because the water leaves it in the form of sublimation, and then it deposits on the packaging because there's nowhere else for it to go, and we consider that deposition. This happens to meat, so the meat gets kind of dried out. This happens to ice cream. We see it all over the place. One of the things you'll notice is that deposited solid is pretty much purified water, and so it doesn't taste like ice cream or meat anymore. It's just water, and it's coming out of the other substance. So again, those are our physical changes. And for sublimation, we would write that as, and I'm going to use water as our example, H2O S for solid, arrow turns into H2O gas. And for deposition, it should be H2O gas goes directly into H2O solid. Now let's talk about chemical changes. So one of the key factors in the definition of chemical change is that you're making something new. You're making a new chemical. So these can be described as chemical reactions. So for example, we might have rusting or tarnishing, burning, bleaching. Those types of things are all chemical changes and chemical reactions. For each chemical reaction, we have an equation that we can write. Now, these equations will show that we've got something new forming. So, for example, for rusting, we might see the equation written as Fe, which is iron, plus O2 turns into Fe2O3, which we call rust. This is not balanced at this point, so I'm going to go ahead and balance it, but you don't need to know how to balance these. And then we could have another reaction like tarnishing. What do we mean by tarnishing? Generally, we're looking at something like silver, which tarnishes and turns into a new chemical called silver oxide. So we start with Ag, we add oxygen to it, it reacts to form, that's what this arrow means, Ag2O, which is a black solid, and when we see it on our silver, we would say, hey, the silver has tarnished. What about burning? What kind of equation would you write for that? Well, this can vary depending upon what you're starting with. I'm going to use a piece of paper for an example, and paper is made mostly out of cellulose, so I'm just going to use that as an example, for which I'm going to write a simplified formula as C6H12O6. We'll talk more about cellulose much later in Unit 5, but just give a basic form of it. And we're going to add oxygen to this, and when that reacts, it creates what we would call fire, and we make ashes and things like that. But we're going to see that we're going to make CO2 and water. Those are the two major chemicals. So we'll write CO2 plus H2O, and we will see that we had a reaction occur because we made something new out of it. And this is the reaction that we see occurs when we bleach indigo. In this case, we're bleaching it with ozone. But we're going to see that we can see a difference between the starting material and the final product. These are different chemicals, so we know that that was a chemical change. And we wrote an equation to show that. And how is this different from those physical changes of states where I wrote H2O liquid turns into H2O gas? Does this differ? Well, the main thing is that I've made something new. Notice when I said H2O liquid turns into H2O gas, the formula of the chemical was still the same. It was still H2O. But in each of these equations, we see that we start with one thing and we end with something different. So that's how we can see that there was a chemical change when we're looking at a test or written out on a piece of paper. But what about when we're in lab and when we're trying to look at an observation to decide, is this a physical or a chemical change? We'll talk about that next. There are 4 signs of a chemical reaction. We consider this experimental evidence that a chemical reaction has occurred. Number 1, we can have a color change. Number 2, a solid precipitate can form. Number 3, a gas can form. And number 4, heat or light is given off or absorbed. You should definitely know these 4 signs of chemical reactions. Let's delve into each of them more specifically. So let's look at color change first. If I add some blue food coloring to some water and it changes to blue, well, that's not a chemical change. But if I add blue food coloring to water and it turns to green, that tells me that there was a chemical change. Something different has happened. What if I add blue food coloring to something yellow and it turns green? Well, that is not a chemical change. So you have to be particularly careful about these. When we're blending colors, you have to know those normal color blends. So red and blue makes purple, yellow and blue makes green. But if we just add one thing and it isn't a color blend, it changes to something completely random, then we're talking about a chemical change. And next we have a precipitate forms. A precipitate is a solid that forms in a reaction. So if I just take some water and I put it in the freezer, that's not doing a reaction. It is forming a solid, but that's a physical change. On the other hand, if I take 2 liquids and mix them together and suddenly a solid forms, that's a precipitation form. For example, here we can see clear colorless lead 2 nitrate being dropped into clear colorless potassium iodide. And when they mix this beautiful yellow solid known as lead to iodide. You can clearly see that the solid is forming and that this is going to be called the precipitate. We can see something similar with gases. In this case, I have on one end of a tube, I have a cotton ball soaked in hydrogen chloride. And on the other end, I have another cotton ball soaked in ammonia. Both of these substances vaporize very readily, as you may have noticed when you've opened a bottle of ammonia and been able to smell it. Now we're going to have both of those gases diffuse through the tube until they come in contact with each other, which you can see in the middle here. At that point, we're starting to form ammonium chloride, a new solid. And that is a gas form of precipitation reaction. We could see a gas forming, and normally what we see here are bubbles forming, but that's not the same as blowing bubbles where you get little circles from soap. That would be a physical change. And it's not the same as boiling water where we just add heat to water and it turns into water in the gaseous form. What we're talking about again is where I mix two chemicals together, let's say baking soda and vinegar, and what you'll see is a whole lot of bubbles coming out of that. That would be a chemical change. And our last one is that some form of energy is coming off of the system or coming into the system. It tells us that there's a chemical reaction. And when we talk about these types of changes, we're really looking at heat or light being given off in general. So what we'll see is that we mix something and we put our hand near it and it gets very hot. That tells us that there's a chemical reaction. If we look at it and all of a sudden it starts glowing, or we see bright light, or we see a flash of light, any of those things would tell us that we had a chemical reaction. So when we shoot a firework into the sky, what do? You see flames, you see light. There's a bright light. That tells us that there was a chemical reaction that occurred when we shot that firework into the air. When you have those little glowing necklaces that you can get at amusement parks, those types of glowing necklaces happen because of a chemical reaction. What did you do? Well, when you first got it, if you know how those work, you have to break this little glass vial that's in there that has a type of peroxide in it, which reacts with the liquid that's inside of that tube, and you'll start to see a glow. And that lasts for a little while, and then it goes away when a reaction is completed. Okay, so now we've talked about the physical and chemical changes. Let's see if you can figure out which ones I'm talking about. So you decide whether each of the following is an example of a physical change or a chemical change. Pause the video, try it yourself, and when you come back, I'll give you the answers. Alrighty, let's start at the top. A red rose turns brown. Well, as it turns brown, we know that there's a color change. That tells us that this is a chemical reaction. Number 2, your mirror fogs up after you shower. What you're seeing here is a liquid coating the mirror. That liquid is water that comes from the shower or from the humidity in the air, condenses on the mirror. Sounds like a physical change. Next, we're going to make some Kool-Aid. To make Kool-Aid, you add Kool-Aid mix, water, and sugar. You mix it all up. This is just mixing. We do see color changes, so if we have red Kool-Aid, it turns red, in that the water now turned red, but that isn't really a color change because we already had red in the food coloring that was in the Kool-Aid mix. So this is a physical change called mixing. Number 4, what happens when you burn dinner? Well, that is chemistry. Not the kind of chemistry you probably wanted to do, but it is still chemical change. Again, you can see this blackened food. The blackness is telling us that it's burning. It also tells us that it's a chemical change. Number 5, you chew your food. Here you're just chomping down on it, you're crushing it, not dissolving it or doing anything else, you're just crushing it, and for that you would say that that's a physical change. Next, the food is digested in your stomach. As it becomes digested in the stomach, the acid in your stomach is breaking it apart into smaller pieces, making new chemicals, and that is a chemical change. What if you boil water to make tea? When you're boiling water, that's a boiling, which changes something from a liquid to the gas, and so that tells us that you're doing a physical change. And number 8, you mix up some chocolate chip cookie dough. When you make the cookie dough, you have all these different parts, you mix them together, Again, that one is mixing, which is a physical change. What happens when you bake those chocolate chip cookies? Well, here you'll notice that they turn browner and they change their texture, so something has changed, and that is going to be a chemical change. And finally, if you have an apple and it rots, what do we see? That is going to be a chemical change because it's going from a nice red apple or with white inside, and as it rots, it turns brown and gets kind of old looking. And that is it. So hopefully you did okay on those.